If you don't understand hash sets like this guy in our photo right here, please don't click off this video because I'm gonna explain what hash sets are. So there are three properties of hash sets. Hash sets are unique. The second thing is size is not fixed. And lastly, in hash set, there's something called hash. So let's go to the first part, the unique part. Okay, I'm just gonna explain everything in terms of an array and how it differs from an hash set. So in an array, basically, let's just have everything on the screen off. In an array, basically, we will have something like values like this. A1, array 1, we're gonna have values 1, 2, 3. And again, we can have values like 1, 2, 3 again here. So what I'm trying to say, overlapping values are possible. 1, 2, 3, 1, 2, 3. However, in hash sets, let's just use blue to show the contrast. After we put values like such as 1, 2, 3 in, do you think putting 1 again is possible? No, it is not. We are not able to put values that we already have in our hash set. So another example is 2 or 3. 2 or 3 is already in a hash set, so we are not able to add them. So what I'm trying to say is in hash sets, we only have unique values. And when I say unique values, I'm saying we only have values that we can only have values that appear once at a time. So this is what's happening in a hash set. Okay, let's go to the second part. In a hash set, size is not fixed, right? So we're going to use this as our example. Size is not fixed. So one thing you may have noticed in an array is we always have to declare the size of array. Let's just say int x1 new int 10. In an array, if you look at this part, you always have to declare this part, basically. You have to declare how big an array is. Int x1 new int. So we are going to have an array the size of 10. However, in a hash set, this does not occur. In a hash set, if you look at, this is how you declare a hash set. As I bottom lined it, blue, we already used blue, so let's use something like green. So this is how you declare a hash set. If you see, as you see in this underline, there is no size in our hash set. So basically, what we do is in hash sets, we have something called load factor. I'm just going to say LF. LF stands for load factor. So what is a load factor? Usually for a hash set, a load factor is 0.05. This may confuse you. Do not worry. We're going to go over this together. Let's just bring this all the way down so we can explain load factor. In a load factor, basically, our hash set starts with size of 16 values. 16 values, right? And if we fill this 16 values up to 75%, which is 12 slots, basically, we are going to multiply our size and turn it into 32 slots. What I'm saying is, to be more specific, in the start, when you declare a hash set, it will have total of 16 slots right here. And if we fill out 75% of that, which is a total of 12, we are going to double our size. Basically, 16 changes into 32. And 75%. If we go over 75% of that, we are going to double it again. Now 64 slots. If we fill 75% of that, we are again going to double it. So the size isn't really, by the way, guys, sorry for not explaining this beforehand. When I'm saying 16, 32, 64 slots, I'm talking about array. So in the core of a hash set is built like an array. So at first it has 16. It is an array of 16 spots. Then it's going to change to array of 32, array of 64, array of 128. We're going to double it each time. And what the load factor is basically is that if you fill up to that percentage and go over that, we're going to resize it. Basically, that's why HashSet doesn't have a like fixed. We don't necessarily declare the size. It becomes bigger as we go on. Basically, if we say we add like 12 values in, we're good. But when you add the 13 value, we're gonna double it. 16 turns into 32, and after we fill out 75% of 32, if we go over that, we're gonna go to 64. So that's what I'm talking about. Wait. Oh, hashtag. So we went over these two main things. So hash sets have unique values and size is not fixed in hash sets. And we have something called load factor. And lastly, we're going to talk about something called hash. So what hash is basically in a hash set is basically usually in an array. Let's just say we have array A1. When you put values, you just put values randomly, right? 1, 2, 3, 4. You just put values where you want to put them. However, in a hash set, there is a very specific way of doing and putting certain values where. And this answered the question of why we use hash sets in the first place. Let's just say we have a hash set called H1. By the way, how are you guys' weather? You know, where my place is, weather is getting better. Okay, so in hash sets, we do something called hashing, basically, to put certain values in. Let's just say we declare something called H1, and we put certain values in here. We want to put value, let's just say we want a random value, 21. 21 in our H1. As I told you, when we declare a hash set, the size is usually 16. So what we do here is we divide 21 by, you guessed it, 16. You're going to divide it by the size. What comes out is not important. What is important is what is left. So 5 is left over. So this is the important part. So on the fifth, fifth index basically, or like index. So it's going to start from 0, the index 0, 1, 2, 3. And when we go to our fifth one, or basically like our sixth index, sorry, basically what happens is we're going to put 21 in that index, not anywhere else. So you may have noticed something very particular. We have a way of putting certain values in our hash set. So let's just do another example. What about values such as, we want to put values such as 17 in our H1. 17, divide that by 16. As I said, what comes out is not that important. What is left over is most important. I'm going to put a double star here, so triple star. Is this 4 stars? Because that's how important it is. We're left over with value 1. So we're going to put 17 in the second index, or the index 1, basically. So what happens here is, you may have realized this, but we put values in a certain way. There's a certain way we do it, and that's called hashing. Basically, sorry, you put values not randomly in where you want it, but there's a specific order and a way, a method of doing it, which is hash, or also known as hashing. And why we use hashes is answered through hashes. Hashes are really good at looking if we have a certain element. Basically, as I told you, we put certain elements by using and dividing by the size, and then like using what's left over as that index. So because of this, let's just say we want to see if in our array we want, which is a size of 16, we want to see if we have val 17. So what you have to do is you have to iterate through the whole thing, basically, if you don't have an algorithm, right? You use a for loop, while loop, I don't care. You basically need to go through the whole array to see if you have 16 and return true if you find it and not if you don't. But for a hash set, all you need to do is really divide it by 16, get the what's left. Sorry, that divide sign is horrible. Get what's left and just put it where and go to that index and look if we just have 16. So compared to array, hashing is way more faster. I mean way more faster because for big O theorem, meaning like how fast it is, it only costs O of 1. While like looking at other, like for example, an array will take like O of n, or like even if you use an algorithm, it will usually be slower than O of 1. So that's why hash sets are so strong. And the main reason why we use hash sets in the first place is because, sorry, let's just take all of this this messy stuff out of here. And the reason why we use hash set in the first place is because, let's just say, again, if we want to see if we have certain values, like 104 in an array. An array, you basically have to look through it. However, in a hash set, all you need to do is you need to like you use a method dot contains, right? And that's all you need to do. In hash sets, there are built-in methods such as let me bring this here. Sorry for the mess. Let's just say we declare it by something using like this. So we obviously say hash set. Then we say integer. This can be a string, whatever you want, and set new hash set. We dot add. We keep adding values here by using the dot add method. And we use the dot contains method. Basically, using dot contain basically allows us to look if we have a certain value, and that's why hash sets are so strong. And we are back with our code. So let's just say we want to add certain values here. x1 dot add 1, x1 dot add 2, right? So this is how you add values, right? And for printing out what values you have, you need to use a for each loop, because you can use an index, a simple for loop, because you don't know the total size, right? Usually. Let's just say it's for int k in x1, we want to print, or sorry, this is out. This out like our k. Let's just try to run it. And boom, 1, 2 happens. We can do also things like size dot size to print out the total size, basically, like how big our hash set currently is. Sorry for this is taking a while. What we all need to do is here. Yeah. Size is, again, 2, right? Let's just put size here. Size, try to run it again. Yes, and size is equal to 2. Another thing you can do, as I told you before, is we can use x1 dot contains. Yeah, x1 dot contains, let's just say true. And let's say we want to print this out, right? We can do something looking like the following. We print this out. It's true right here, right? So what we can do is oh yeah, sorry guys. We always have to import Java util.hashsets, and what we do is we can It's very useful for using hashes because in Java, we can do dot contains. So if there's like any question that says if you like search if we have a certain value, then we just all we need to do is dot contains, right? And this is really helpful in Java. And guys, this is it for this video. If you have any questions, please leave a comment. Thank you so much.